Imagine somebody hands you a piece of paper that looks like this. It's got a maze on it, right? Obviously, we got A with a point and B with another point down here. Now, if you were given this, what would be your first instinct? Probably, like most people, you've seen mazes before and you know how to solve them, right? So you could say, well, you would start at A, right? And then you could travel through and realize maybe there's some dead end. Okay, then, this isn't a complicated maze here. But the maze isn't the point. The point is about how to approach problem solving. So you might try to go straight from A to B, moving around, maybe making some mistakes on the way. When you're given a problem like this, you have assumptions that you're bringing to the table, right? You assume that you're supposed to solve the maze, for one. That's an assumption. You assume that you're going to solve the maze the way you solve other mazes. And the point of this is to check your assumptions, because nowhere on here does it say, it doesn't give you any kind of instructions or rules or anything. So real problems are like this. Problems that you get in school are not like this. There's a specific way to solve them. They'll often give you rules telling you what to do, or you have been taught the rules and the procedures. But you're seldom going to run across problems like that, where there's a procedure where you follow number 1, number 2, number 3, number 4, and then you get the answer. A lot of problems in life that you'll come across, the important problems, don't come with a procedure for how to solve them. So when you're faced with them, a good thing to do is check your assumptions first. I mean, you can try solving it first as well, but at some point you should check your assumptions and make sure you're solving the right problem and you're solving it in the right way. So for example, and this is something called lateral thinking, and this isn't a topic that you're probably going to run across in school, because how can you test for lateral thinking? It's an abstract idea, and the answers there can be so many different answers that it's difficult for a teacher to create a test, for one thing, but also to grade the test. Like, how would you do that? So this isn't something you're likely to ever see in school, but it is an important skill to learn. And in mathematics and in science, in technology, in all kinds of fields, you're going to run across something, not a maze, obviously, but something that I'm trying to illustrate here. So maybe you get stuck somewhere just trying to follow the path from A to B. Well, what if you said, what if I start at B and work backwards? That's an assumption. We assume that we would have to start at A and go to B. So we could actually go in here and say, okay, I can't go that way, I'll go this way, that's a dead end. Oh, now we've solved the maze. Okay, great. Now, are we making other assumptions about this problem? There's nothing that says we can't do this. We can go around the maze, maybe. Why not? I mean, nobody's stopping us. We could, if we were so inclined, we could just go straight from A to B. I mean, is there any rule saying that those black lines stop us from moving through? Maybe that's a thing you can do. Maybe you can think in 3 dimensions and you can actually go up and over the maze and solve it like that. That's another possible solution. Imagine that you were given this on a piece of paper, like here's a maze here, and you have A and B. Another thing we could do is fold the paper together so A and B are touching, and punch a hole right through, and now they're connected. This is something you might see explaining how wormholes work, for example. Wormholes avoid traveling through space by folding dimensions and traveling through a hole that goes in between. This isn't strictly forbidden by the laws of nature, so it's entirely possible that that's a solution as well. You could actually do nothing. That also might be a solution. There may be no problem here. So the point is, question the rules that you think you have to follow. You might not have to follow them. Now, your teacher's probably not going to let you do this in school. It's not going to fly. This is something called lateral thinking. It is looking at a problem, and instead of going in a linear fashion, which means following a line from one thing to the next, when we think laterally, we can travel that line for sure, but if there's points where we get stuck, we might actually make the decision to hop over to a different line and use a different line of thinking. So we're allowed to be incredibly creative with lateral thinking. And one of the things that really helps with this technique is to know a lot of different things about a lot of different fields, because you never know when you're going to find something that works in one area that will actually work in another. And this is the power of having breadth of thought and not just depth.